Hello everyone, this is group 17 with Chandrakant Bogra, Sandesh Pokhrel and Venkata Naveen Gade. Today we're going to be reviewing two papers, a roadmap of agent research and development and multi-agent learning for engineers. So first of all, what are agents? Agents can be defined as a computer system operating within an environment and equipped with the ability to act in independent manner for a goal. There's three aspects to this definition. Situatedness, meaning system can take in data of sensory manner through its surrounding. And then we have autonomy, meaning the system can operate even without human intervention and can control its state. And then we have flexibility, which comes in three aspects. A system has to be responsive, meaning it has to respond to the sensory input from the environment. It has to be proactive, meaning not just simply reacting to changes, but like the agents also need to have a sense of opportunities present in the environment and then make decisions. We also have the social aspect of it, meaning it should have the ability to communicate and work with other humans and agents. Tracing the history of autonomous agents will help us understand different work that contributed to the research and development of agent-based system. So there have been three main contributors to this field of agents, and those are artificial intelligence, field of object-oriented programming and concurrent object-based systems, and the third one is human-computer interface design. Artificial intelligence is the field that has contributed most to the field of agents. But before 1980s, most of the field broke down intelligence into chunks of various parts of intelligence, like learning, reasoning, problem solving, and they thought that combining these different intelligence studies would lead to creation of an agent that can utilize all these different aspects. AI planning is a subfield of artificial intelligence, and it is the knowledge of what to do, what actions to perform. And we have a planning system mostly influenced by Newell and Simon's GPS system, but we also have STRIPS planning system, which has symbolic model of agent's environment and then symbolic specifications of actions that agent can perform. And we also have this planning algorithm that can receive input data from the surrounding and then provide output of plan that can tell us the process that the agent will utilize for reaching its goal. The problem with this system is that in realistic scenarios, there's a problem of calculative rationality, which is concerned with a system that can that needs infinite information to give us the optimal decision that we can take. But in realistic scenarios, most of us may not have that time that this system needs to take in all the data, and the time to take the decision may already pass. We also have subsumption architecture by Rodney Brooks that was actually based off criticisms leveled towards the strip system. In this system, we don't have any symbolic representation or reasoning. We just have collection of task accomplishing behaviors, and decisions are based off this communication or interaction between these behaviors that are collected in hierarchical manner. We also have other architectures. We have hybrid architectures that combine deliberative and reactive approaches of the previous architectures. They utilize vertical layers when they need to ensure only one layer can make use of sensors and effectors, and they utilize horizontal layers if they need to ensure every layer can use sensory input and action output. We also have practical reasoning agents, which are based of system of reasoning inside humans. Our psychology is based of things such as beliefs, desires, and interactions. So practical reasoning tries to replicate that for its agents. So we have practical reasoning interactions such as belief, desire, intention model, which uses the surrounding for input for its beliefs and then uses those beliefs to list the availability of different opportunities. We also have the field of object and concurrent object systems. Objects can be defined as elements of computation that sums up a state, can act or utilize methods on the state, and use message for communication. Despite their similarities, objects and agents are different since agents are way more autonomous and have a thread of control that objects don't. And objects are also less flexible compared to agents because most object model don't need flexibility of being reactive, proactive, or social. We also have the field of human interfaces that contributed a lot to our development of agents. Most human interactions require a human to give out orders for a system to perform an action, which is called direct manipulation. But with agents, we need agents to initiate an action instead of waiting for human input all the time. This type of agents are called expert assistants, and the researcher Nicholas Negroponte provides example with a telephone agent that takes a call, determines the caller, and informs you if the circumstances demands it without any human intervention. Historically, multi-agent system research referred to research on distributed artificial intelligence, which can be separated into distributed problem solving and then multi-agent systems. Nowadays, though, MAS refers to any system that utilizes more than one semi-autonomous agents. DPS systems target problem solving by determining the solution through number of modules called nodes that separately target a problem and then communicate their findings and solutions with each other. But in MAS, all the different behaviors of the agents are directed towards solving a given problem, meaning all different behaviors which cannot solve the problem individually collect together and utilize each other's expertise for problem solving. MES has following characteristics: incomplete knowledge about the problem, no global system control, asynchronous communication. History of MES began with researcher from Dye workshop in MIT when they researched into problem solving through utilization of a system that has multiple problem solvers. First model of multi-agent problem solving was called actors models. Actors are independent parts of computing system that can operate by itself and then communicate asynchronously with each other through messages. The primitives of actors are create, making an actor through description of different behaviors and list of working parameters. Send, provide messages to other actor. Become, make changes to actor's local state. One application of multi-agent system is task allocation through the contract NATE protocol. Davis and Smith worked on contract NATE protocol that tackled the issue of providing tasks to multiple nodes. They came up with agents of two roles, manager and contractor. Agent separates a task into subtasks which can be tackled in concurrent manner. This system uses CNP for determining transferable tasks and asks nodes to bid if they can conduct those tasks. Then the contractor uses those bids to determine which node is best suited for this task. This system has been applied in air traffic control, distributed vehicle monitoring task, and then Blackboard.
Hello everyone, my name is Chandrakant. Today I will be saying my research about applications of agent technology. The field of autonomous agents and multi-agent systems is vibrant and rapidly expanding in areas of research and development. Agents are first being used in industry applications and now are being used in a wide range of industrial systems. Coming to the industrial applications, agents are used in manufacturing, process control, telecommunication, air traffic control, and transportation system. When coming to manufacturing, due to the global competition and the rapid changing of customer requirements, these are forcing industries to change their production styles and configuration of the manufacturing organizations. Uh, how a agent can be induced in manufacturing. A single company or organization may have different factories, and through these factories they may duplicate functionality and capabilities. The goal of agents is to manage the production process at this plant so that it reduces the cost of production and optimizes the process. Coming to the process control. Process control is a natural applications for agents. These are agent-based process control system and that are written for monitoring and diagnosing faults in nuclear power plants, spacecrafts, climate control, and steel coiling systems. When coming to the process control, agents are naturally process-based systems. They work on processes. And telecommunication systems are large distributed networks over the world, interconnected components which can be monitored and managed in real time. Telecommunication systems companies are service providers aim to distinguish their products by competitor by providing better and quicker and more reliable services. When coming to agents in telecommunication systems, uh, they can be used as chatbots and virtual as call assistants because when a customer can directly uh, complain to agents, the agents can find out the keywords in the chats and give the solution according to the complaint. Air traffic control. Uh, Agents can be used in air traffic control. For example, an aircraft might have a goal to land on a certain runway at a certain time. Air traffic control agents are responsible for managing this system. In this way, the agents are used in air traffic control. The domain of traffic and transportation management is well suited for the agent-based approach because of its geographically distributed area. For example, let us take a carpooling system. In carpooling, a customer is an agent and the pickup is an agent. So whenever the agent places a request of a pickup, the another agent who is going to pick up analyzes the place where to go, time when to reach, and allocates the car according to the need and reach. Coming to the agents in commercial applications, AI can be used in any business in three fields, such as automating business processes, gaining insights through data analysis, and engaging customers with the employees. Coming to commercial applications in the real life, agents are used in information management, electronic commerce, business process management. There is a huge competition between the different companies in the market, and every company wants to be top on their game. Even smaller companies incorporate artificial intelligence into their business to be successful. Coming to information management, due to the lack of effective information management tools, has given rise to the collectively known as information overload problem. And there are two categories information overload problem, that is information filtering and information gathering. What is information filtering? Uh, there is a lot of information out available in the world, but we only choose certain items which we want to access and which are useful to us. This is known as information filtering. Information gathering, there is a raw data out available there, and putting all this data to give meaningful insights and saving the data for further data analysis is known as information gathering. Multinational companies uses features of AI like automation, big data analytics, natural processing language to get their business insights and make more efficient and they're relevant to the customer base. Coming to electronic commerce, chatbots and other virtual assistants are available so that there is no need of human intervention between them. And in the electronic commerce, nowadays agents are being used to give intelligent product recommendations. And There is one more example, e-commerce AI tool such as the Google Duplex tool is developing capabilities like creating its grocery list, and even if you have the access, it can even place the order in the grocery. In this way, the AI agents are used in the commercial electronics. Coming to business process management, applications in this system include for supply chain management, a system for managing heterogeneous workflows, a system for mobile agents of inter-organizational and workflow management. In this way, agents are used in commercial applications. Coming to agent technology in entertainment applications, agents have an obvious role in computer games, interactive theaters, and related virtual reality applications, such as to be tend to semi-autonomous animated characters, which can be naturally implemented as agents. Uh, Coming to games, interact uh, games create rich, stimulated environment containing a number of synthetic agents that a user can interact with in real time. Uh, if you can take, for example, if you play a VR game, you can interact with other characters in the game and play a story-based game based on the concept. And coming to interactive theater and cinema, by interactive theater and cinema means we mean that allows a user to play out a role which is already played by a real human being or a character in a play or film, interacting with artificial intelligent computers characters. They these that have a characters of a real human being. Jumping on to agent technology in medical applications. Medical field has grown a large in last few years due to the new applications that are found in the technology and due to the medical advancements in the health industry. Artificial intelligent computer systems are used very extensively in medical sciences. Common applications include diagnosing patients end-to-end drug discovery and development, improving communication between uh, patient and the physician, transcribing in medical documents such as prescription and remotely treating patients. AI has the ability to analyze big data sets, pulling together patients' insights and leading to predictive analysis. Quickly obtaining patients' insights helps the healthcare ecosystem to discover key areas of patient care that requires improvement. Uh, Wearable health technologies also can be used as AI to better serve patients. Nowadays, there are many wearable health AI tools such as uh, ECG, watch ECG, and an ankle monitor, and you can check heart rate. You can check the oxygen levels. In this way, a patient can be monitored by using wearable AI things. Sure. And finally, coming to the futures of agents, the field of autonomous agents and multiple agent system is a vibrant and rapidly growing area of research and development. At its core of autonomous agents reacting with another, the individual or collective goods, the basic conception of the framework has become very currency in the range of closely related disciplines and offer a natural powerful means of analyzing, designing, and implementing a diverse range of software products. These technologies are now beginning to find their way into commercial products and real-world software solutions. So you can easily imagine that agents can be used in everywhere of the world. Thank you.
I myself, Venkatana Vingade, I am discussing about the multi-agent learning for engineers. Multi-agent learning for engineers. If multi-agent learning is the answer, what is the question? We address this inquiry by introducing the difficulties, probabilities by designing applications and taking about the likely allure of multi-specialist figuring out how to meet these difficulties. Multi-agent learning. Multi-agent learning may involve multiple learners, each learning and adapting In the context of others, these introduce game theoretic issues to the learning process which are not yet fully understood. Multi-agent systems contains a number of agents which interact with one another through communication. The agents are able to act in an environment where each agent will act upon the influence different parts of the environment. Learning agent architecture, performance standing, critic, learning element, problem generator, performance element, and environment. Approach. The main idea behind multi-agent learning approach is to learn the critic for each agent by selecting, paying attention to information from other agents. Learning agent. A learning agent in artificial intelligence is the type of agent that can learn from its past experiences, or it has learning capabilities. It starts to act with basic knowledge and then is able to act and adapt automatically through learning. Components of learning agent. Learning element. It is responsible for making environment learning from the environment. Critic. The learning elements take feedback from critics, which describes how well the agent is doing with respect to a fixed performance standard. Performance element. It is responsible for selecting external action. Problem generator. This component is responsible for suggesting acting that will lead to new and informative experiences. One shot. One shot game. The game that may played only once. The payoff may be such that a game might be impossible to play twice. Example, mutually assured a nuclear destruction, slightly different with tactical conventional welfare. Learning clearly about information is very important in such games. If the agent make any mistake without learning environment, it will cause overall destruction of environment. Nash equilibrium. Company A and Company B both companies want to determine whether they should launch a new advertising campaign for their products. Explanation. If both companies start advertising, each company will attract 100 new customers. Company A, Company B, advertisement, do not advertisement, and Nash equilibrium. A game may include multiple Nash equilibria or none of them. Nash equilibrium is one of them fundamental concepts in game theory. It comprises the behavior and interaction interpersonal skills. Interpersonal skills are the skills required to affect communication, interact, and work with individual and groups. Main use of Nash equilibrium in multiple agent learning is to maximize their own cumulative reward. It is not easy to communicate between agents. It requires so many resources. If we continue without interaction with other agents, then it will lead to a distraction of environment, and communication with other agents cannot be predefined because you cannot able to predict the moves of their agent. Conclusion. In multi-agent learning, each agent should have the domain knowledge and also should have the capability to recover from failure. Agent should perform actions in such a way that the reward should be maximized. Advantages of multi-agent systems. A multi-agent system provides solutions in systems where exploit is spatially and temporally distributed. An multi-agent system enhances overall system performance, specifically along the dimensions of computability, computational efficiency, reliability, extensibility, robustness, maintainability, responsiveness, flexible, and reuse. Disadvantages. Maintaining communication among agents is not easy. Thank you.